Innovation, creativity, leading the next industrial revolution. These words describe, first of all, our STEM finalists, the winners, and the students that participate in their programs, but it also describes MakerBot. Now, when I say MakerBot, I know that everyone's excitement, probably their blood pressure goes up a little bit and they start to get excited. I personally get excited because MakerBot turned my high school sophomore not really engaged, had some learning difficulties, and the MakerBot system, the MakerBot ecosystem, and the interest in MakerBot products turned this disengaged high school sophomore into a straight-A student, high school senior who is a budding engineer and is now going to an engineering school. And I relate that all to MakerBot. So having MakerBot here is very, very important to all of us, as well as a personal story for me. Our keynote. Since joining MakerBot in early 2014, our keynote speaker, Yuri Salnikov, strengthened the MakerBot brand and firmly established the MakerBot 3D ecosystem. Yuri began his career as a marketer at Colgate-Palmolive after graduating with an MBA in marketing from the Kellogg Business School. Yuri is an avid tinkerer. Probably the best place for him to be is at MakerBot then. He loves spending time with his family, his 3 kids, advising startups, and actually participates in long-distance cycling in his home county of Dutchess County, New York. So please help me in joining Yuri to the stage. Thank you.
Good morning, everyone. I'm Yuri Salnikov with MakerBot. I am not Jenny Lawton. And on behalf of her, I have to say she's very sad that she couldn't be here today. At the very last moment, yesterday morning at 10 o'clock, she had another unexpected meeting that she had to attend. So that was at 10 o'clock. So at 10:01, I got the phone call to say, hey, I can't make it. Can you jump on a plane and please go down and present what I was thinking about presenting? So I'm here down in Orlando. And by the way, the weather here is a lot better than it is in New York City. And I am very excited to talk to you about MakerBot for a couple of reasons. So thank you for coming in and listening to me this morning. The title of the presentation today is 12 Years From Now. The reason that we chose that title is that right now in 3D printing, there is so much hype. Every day that you open up a journal, that you read a magazine, there's a new innovation, there's a new technology that's arriving around 3D printing, and everyone is wondering when will 3D printing become adopted for all masses. There's a real push. And actually, we get it from the marketplace. Everyone's saying, when is it happening? How is it going to happen? And is it going to happen tomorrow? And actually, we're taking a stance and saying that based on what we've seen from the market in the last couple of years, we think actually that mass adoption for 3D printing will really happen in about 12 years. And why 12 years? Is because that's the time that it's going to take students to get through a school. So if they start in the first grade and they get an introduction to 3D printing, and it's incorporated in the curriculum, basically in about 12 years from now, we think that 3D printing is going to be ubiquitous. So I'd like to play a video about MakerBot, and it's actually not about MakerBot, but what educators are doing with MakerBots and 3D printing. And so why don't we roll with the video and I'll talk about it afterwards.
It's always better when students create their own things.
From kindergarten to 11th grade, everything was on a piece of paper. And that wasn't as cool as having the project in your hand.
The MakerBot and the new era of rapid prototyping is opening up the field of engineering as a whole.
So I'm teaching them how to be creative and and how to solve problems.
It's the kind of thing that will give them a better chance of starting a career with that kind of knowledge.
There's going to be things they do here, and they're going to get to college, and the teacher's going to go, oh, well, okay, you're good.
Before, it was just in my mind or on a piece of paper and on a computer.
If you're going to engineer something, it helps to look at every angle you can.
These students are going to need to learn to be able to create in 3D and print in 3D, and not just print in 3D with plastic.
I'd like to see it used in every department on the campus. Our vision is that it's an important tool that will be used cross-disciplinary.
Having something that you design print is like the coolest thing.
My favorite part of 3D printing is that I get to create something that may have never been made before.
So from our perspective, I think this video really encapsulates why we get up in the morning and we rush to go to work, because you see the power of 3D printing, right? We've developed a hardware, a software, that when it lands in a school, so many unexpected things happen. So today, in terms of the presentation, what I'm going to do is I'm going to try to unpack some of these, what's happening actually in schools and what we're seeing. MakerBot is actually in a unique situation because the company is about 6 years old, and it's really one of the first companies, if not the lead company, that helped bring 3D printing from the professional space, where printers are hundreds of thousands of dollars or millions of dollars cost, to something that's more cost effective. And MakerBot brought in a reliable printer, and we've seen what's happened with the printers as they've been brought into schools. One of the things that I'm sure you know as educators is sort of technology adoption and how does it happen over time. I think that you would agree with me when I say that technology is basically brought in initially and it's a niche product. And actually what we've seen is that educators are the ones that initially embrace the new technology. And then as the technology is brought into schools, the students are introduced to it, they get this amazing skill set, they go out, they pitch themselves for jobs, the people who are hiring them realize that they have special skills, they bring them on board, they get integrated into companies, and then they turn around and start hiring other folks who have similar skill sets. So this is not a new story. We actually saw something like this with mainframe computers. Mainframe computers were used by corporations for about 30 years, and then they started introducing desktop. If you remember back in the 1980s, with 1984, Steve Jobs, the commercial, right? That was the introduction of desktops. And what happened is that a lot of schools started adopting desktop printers, setting up desktop labs. Students started using the computers there. They found out that it was very useful, so then they wanted to use it at home. And then when they were interviewing for positions after school, guess what? They were demanding that these companies would have a desktop. So we've seen this trend before. So we believe that we're basically at an inflection point now where more and more schools are adopting the 3D printing technology, and they're playing with it, they're testing it, they're incorporating it within their curriculums. And what I'm going to share with you are a couple of examples of some interesting schools that have brought on board the technology. And I just talked through this model essentially that you are at the pinnacle of technology adoption. You bring it in-house, students learn from you, they get the skills, and then they go out and they're hired by companies. This is a simple example of 3D printing and what can be enabled. So one of the things that MakerBot launched about 5 years ago is a community called Thingiverse. On Thingiverse, we have over 500,000 free downloadable 3D designs that is community generated. And on this community as well, MakerBot creates models. One of the models that we created was the T-Rex model. And we had a hypothesis. We said, all right, you know what? What is the most fierce dinosaur that's out there? It's the T-Rex. What could be interesting for students to actually learn about? Well, the T-Rex. And typically, how do they learn about it? They open up a book, they read about it, maybe they'll watch Jurassic Park or something else. But we had a theory of what happens if you actually create a 3D model that teachers can download and actually print in their classroom. And that's what we did. So our design team actually developed an anatomically correct T-Rex model. 79 bones in total. Actually, when we first launched it, it had 78, and then one of our guys noticed that, and so we fixed it. So there's 79 anatomically correct bones for the T-Rex. So what you can do with this model, actually, is you can download the file and print it. It takes about 24 hours to print in multiple pieces, and then what we've seen is that teachers are taking the model and they're assembling it with their students. So what a different perspective on learning about the T-Rex, about prehistoric creatures, when you can actually print it, look at it, and put it together. Another example of what we're seeing out there is this one. Laura Talman is a former professor who actually now is the resident mathematician at MoMath, which is a museum for mathematics in Manhattan. What she saw as a challenge was that she wanted to teach complex mathematical models. And instead of teaching it from a 2D perspective, what she started doing is that she started designing by herself these models that could explain, and I'm not a mathematician, but can explain these abstract ideas in a very concrete fashion. So she would design it, she would print it, she would share it with the class would look at it, they would touch it, they would feel it, they could examine it, and once again, what a difference of taking a very flat sort of 2D conversation, or maybe a drawing in a book, and actually coming out with something like this. A third example is, and actually we're going to have a video, is a school that's based in Nanuet, New York, where there's a teacher, Vinny, who is head of science, and he had this idea about how to teach physics in a more engaging fashion. And how do you ground it with the classic derby race car? So what he did is that he used a MakerBot, he created a curriculum, a class around it, and he set up a challenge for his students to build the fastest, best car. Why don't we roll the video?
I'm Vinny Garrison. I teach technology here at A. MacArthur Bar Middle School. I'm teaching the 5th, 6th, 7th, and 8th graders. The kids design a car, they build a car, they race a car. The car is based on weight. So they know if they make the wheels as thin and as light as they can, it's going to be a big advantage. Last year was the first year we started 3D printing wheels. It's doubled kind of the engineering aspect of it, really. They were designing the car and building the car. Well, now they're designing the wheels and building the wheels. For what I do in here is I talk about form and function. You want to make something fast, we're dealing with function. I'm going to set up the track. Guys, your cars need to be here if you haven't raced, okay? All right, you guys are up. It's trigger time. Alrighty, guys. Hey, we got 2 cars coming. Heads up.
You guys ready?
3, 2, 1.
Melanie, you are the winner.
Every kid got at least 3 or 4 runs. I would take their best time, and I'd use Excel and put them in order. I started a new list last year, and at the time the record was 0.701, and now it's 0.643. It's 0.05 of a second. It doesn't sound like a long amount of time, but in this it is. I guess they put it together. They really put together the weight to speed. They understood that ratio. Now it's like an arms race in terms of how light, how thin, how much wheel can I leave? You know, it's completely engineering. I have kids engineering parts that don't exist. They're starting from nothing and they're making stuff that they're using. There's going to be things they do here, and they're going to get to college, and the teacher's going to go, oh, well, okay, you're good. You know how to do this.
So isn't that so inspiring? You look at that and you say, my gosh, that's why I said in the beginning of the presentation, this is not about MakerBot, it's about what teachers and schools are doing with 3D printing. And I just wanted to point out a few things. If you take a look at Vinny, you can see, boy, is he passionate about what he's doing. And he stood back and he said, here's a 3D printer, how do I integrate it? Let me try something. And you can see how much love he has for what he's teaching, and then look at the reactions of the kids. They're just blown away by it. So when you see stories like that, you know, boy, does it motivate us back at the office. One parallel to make with this as well is that there was an interesting quote that he said, it prepares kids for college and for ongoing schools. Well, this is an example of an engine block that was actually designed by the engineers at Ford, right? So you see the direct correlation between what the kids are doing in the classroom, building a derby race car. And you could say, well, it's a game. What are they doing? That's not a game. It's amazing because it's helping them think differently. And frankly, they can imagine them going into a job interview 10 years from now or 12 years from now and saying, I did this in my derby race and this is why I want to be an engineer. My next example comes from a school called the Whitby School, which is in Connecticut. It's the oldest Montessori school in the United States, over 50 years old. They have Montessori as well as IB teaching. And here is an example of a teacher, Leslie Perry, who, different focus. She wanted to focus not on derby race and physics, but more on geography. So with the support of the school, she started exploring how can she introduce the curriculum of geography to her students. So let me run the tape and just say a couple of words after that.
The future of using 3D printing, I think, is here. My name is Leslie Perry. I teach design technology, so I'm teaching them how to be creative and how to solve problems. My goal is to spark an interest in the students. This is the design technology classroom. The most popular part of our room is our MakerBot 3D printers. We have a number of them. The students come in here and they're like, are we 3D printing today? Are we 3D printing?
My name is Jessica and I go to Whitby School and I'm in 6th grade. We learned how to move shapes around and put them together, make it so you can rotate and you could see all the directions.
When they first see the 3D printers, they're really, really excited to use them. That's what gets them focused and excited to get going. I found a tutorial to help them to learn by making a boat, and that's how Whitby Harbor was born.
My name is Bruce. I am a 6th grader. The last project I worked on, we were making anything related to a harbor, so houses, docks, boats.
I got to figure out what I wanted to do, what shape I wanted to have, if I wanted to have steam coming out of the top of the boat.
These students are going to need to learn to be able to create in 3D and print in 3D, and not just print in 3D with plastic.
My favorite part of 3D printing is that I get to make whatever I want to and use my imagination to create something that may have never been made before.
They figure something out, they print it out, maybe it fails, but they're learning every time of how to make that better.
Most basic concept I've learned is to go through what we call the design cycle. First, think of an idea, then make multiple versions of it, and then evaluate which one is the best, and then continue pushing it further until it's perfected.
I don't care what industry you're in, you're using that process of improvement all the time, and they're learning that in a natural and fun way.
For me, I think there are two aspects of that video which is so powerful. As you listen to the two kids, 6th graders, and he's talking about how he's designing and how they're thinking, and you can see how it's impacting what they're doing. It's not 2D, but they're actually thinking through problems. The other aspect is that there's this idea, fail fast. Because with a desktop 3D printer, when it's sitting on your desk and you create something and you print it, you can monitor it. It's sitting right there next to you or down the hall, and you can see if it fails. If it fails, you stop. Not a big deal. You put it off to the side. In terms of cost, to build a T-Rex model, a version that's standing like this is about $20. This is about $20. This is about $10 worth of materials. And this is something like $3 of materials. But the idea that you can go in there, you explore, you're trying something, and a child fails, big deal. Go make another one. The other thing that really stood out for me when I talked to Leslie about this is that she had to create the curriculum herself. This is all new, right? We're very early in the adoption phase right now. So what a common thread that we're seeing amongst educators is that they're going out there, they're passionate about certain items, and they're trying things and they're testing it. And they're creating things themselves, lesson plans, etc. They're taking advantage of the models that are on Thingiverse but then they're creating their own engaging lesson plans. So she has an idea of her next project where she wants to create a bobsled run based on the bobsled run that's up in Lake Placid. So we've talked about sort of some easy things to do in terms of the T-Rex. How do you take that and incorporate that into your lesson plans? Or how MoMath is doing it with mathematical designs. We talked about a little bit about the Whitby School, what they're doing, as well as the school in Nanuet. This is an example of a school that's actually taking it to a different level. SUNY, the State University of New York, has been looking at 3D printing over the last several years. They actually had some professional sized printers. And what they decided to do this year is to push the envelope and actually bring in a number of 3D printers. So they brought in about 30 MakerBot 3D printers, as well as our MakerBot 3D digital scanner. And they set up an innovation lab, and they opened it up to the school. So they opened it up to the teachers, to the students, and it was a mix of students. And in fact, some of what we've seen is that the students who are focusing on jewelry have been interacting with the students who are focusing on mechanical engineering, because they're both creating and they're both using this lab. So here's a quick video on that.
It's always better when students create their own things, and I think this is a way to do it where it's both used, in the classroom and in the labs, but it's also something that's training students to think in a different way. My name is Dan Friedman. I'm Dean of the School of Science and Engineering at SUNY New Paltz. The Innovation Center is an array of 30 MakerBot Replicator 2s and 2Xs. This is the campus center for being able to 3D print. I think MakerBot really wanted to have a good place to showcase the first Innovation Center, and we had a meeting with the MakerBot leadership team in December, and then we had the opening in middle of February. So this all came together in about 3 months. As soon as the center started announcing open hours, people started coming, and not just sort of coming to look in, they were showing up with files that they wanted printing out, and that was just getting started. I think it's going to keep building. The reason that we did this is because we see this as a technology that is just starting. I mean, it's going to become increasingly important, and in a lot of different areas, if students come out of here knowing how to use 3D printing and different applications of it, it's the kind of thing that will give them a better chance of starting a career with that kind of knowledge.
When I was looking for graduate schools, I was interested in what technology they had available to the entire school, what was available within the program, and I knew that there was a strong 3D printing base here at SUNY New Paltz. I had an assignment in my undergrad that was to produce a light. The bulb for this light was initially printed in an objet printer, and it cost me about $75 to produce. The bulb that I printed here cost me under $1. With access to the lab, I can now have a new bulb in whatever color I'd like within 2 hours.
I think we can attract some really outstanding students who are undecided between science and engineering and art, and be able to say to them, you can pursue your interests in both areas, and we're going to do things to make it easier for you to do that.
With training, it's not about teaching people, it's more about changing the way that people see the world. At MakerBot, we look at ways that we can make everything better, and in training, we hope to extend that look to others.
I'd like to see it used in every department on the campus. Our vision is that it's an important tool that will be used cross-disciplinary, not just in science and engineering and fine and performing arts, but there'll be applications in education, in the liberal arts and sciences department, social sciences and humanities. We really see this as something that's going to be useful across the campus.
And so that was SUNY New Paltz earlier this year. And then we're incredibly proud and excited that earlier this year, actually, there's a new university about 40 miles away from here, Florida Polytech. They came to us and said we would like to make STEM the centerpiece of the university, and we would like to include 3D printing. So you can't imagine what an honor it was for us to actually work with all the folks at Florida Poly to open up an innovation center there. What's interesting about this model is that, and that's why I'm including the photograph, right? You start thinking about, okay, adoption of this technology. Well, back in the 1980s, what did universities do? They set up their personal computer labs. So you could go in there and there was a monitor there and you could actually use a personal computer, right? Well, now what's great is that with the hardware that's there, there's software that's embedded in it, and we have a software management platform that you have an IT person who's managing it. So this is at a much larger scale. So this goes to the point that it's not one size fits all. You could actually use one printer, you could use multiple printers, and Florida Poly has decided to move fully and firmly into this, and they have something over 50 printers that are working and accessible to their students. The Yale School of Architecture is another school that actually uses the printers extensively with the architecture school, and one of their concepts is like, well, why do we need to have actually the Innovation Center be the center of it? Why don't we put printers in different parts of the campus so that people can get exposed to that and get intrigued and try it as well? So this is my last video to show in terms of Florida Poly. Had to show it since it's right down the road.
The state of Florida envisioned our area of the state to be a tech corridor, Silicon Valley-like feel, with Florida Polytechnic University as the hub.
So the goal is to grow the surrounding area right around the university into a research park and use the university to attract high-tech industry into the area.
When considering selectivity at a university, especially at Poly, you have to look at three things. First is the physical location of the building we have been blessed with to have. Second, you look at the technology that we put in the space, the MakerBot space, the supercomputers. And third, you look at the scholarship. Those three things were the perfect storm for us being very successful in our first year.
The RAD Makerspace Innovation Academy is a facility here that integrates almost 70 pieces of equipment, from 3D printers to filamentation systems to scanners, measurement tools.
By having this capacity of printers and workstations, then students didn't have to be in a special program here at the university. Any student in any major and in any concentration can have the experience of using the 3D printers, all because of this RAD Makerspace.
It's really something special when you have a whole lab of just 3D printers to your disposal, you know, and it's a great experience, and it's something that is one of a kind.
It's awesome being the first group of students to come in.
It's already successful. It's already introduced inspiration into students. It's already cultivated opportunity within the local community, and it's brought in interest at a global scale.
The buzz that got around the MakerBot space has drove an incredible amount of traffic to our website, then turned into inquiries, that turned into applications, to eventually enrolled students. When you're looking at 400 or 500 hits a day coming in from Google alerts, you could not pay for that.
These students want careers. They want to be entrepreneurs. They want to be innovative and create new things. That's what engineers do. And we're attracting the best students in this area of the country and from coast to coast to come to Florida Poly because of the RAD Makerspace.
So the interesting ripple effect of this initiative that Florida Poly is doing is that it's actually attracting a lot of attention from local businesses. So they now have business folks that are coming in to see what is going on at Florida Polytech, and they're will be interviewing students from Florida Poly. And as well, what was interesting is that this initiative has garnered international awareness, and now Florida Poly is also getting student applications from outside of the U.S. So we're really excited, and basically we're really excited to see how this continues. So just grounding the conversation, and I hope all of these examples have provided that this is all authentic, it's real. Instead of me standing here telling you about our 3D printers and why they're the best, etc., I think it's so much more valuable to see what people are doing with them, and it's so unexpected sometimes. This is an example of a couple of companies that are also using 3D printing. Martha Stewart came and visited us last year. She saw the technology of the 3 new printers and she said, okay, I need to bring this into my design studio. So her designers back in New York are all using 3D printers. They're prototyping, they're creating, they're printing, and they have a saying basically that one prototype is worth 1,000 meetings. So what happens is that these designers come in with multiple designs and they sit down and they lay them all out on the table and they evaluate it and they can make decisions a lot faster. Another example is First Build. That's actually the innovation lab for GE. So what GE is doing right now is that they're looking at their manufacturing, they're looking at their products, and one thing that I never knew was that actually when you launch a product, you have to keep about 20 years of inventory on various pieces and parts. So now they're looking at it as a way, well, can we use it in 3D printing to prototype new products up front? Can we possibly launch products that then consumers can prototype products for their GE products? And then afterwards, towards the end of a product life cycle, why should they keep all this inventory? And is there a way to go from real-time prototyping to real-time manufacturing where they have less inventory? So they're looking at it. Sesame Street, another brand that we've been working with. Sesame Street has a treasure trove of characters. My favorite is Elmo. And so they came to us and said, we have all of our wonderful characters. Many of them are not featured. We'd love to pilot something with 3D printing. So we went from an initial conversation to helping design their 3D models to launching it. And Sesame Street has come back and said that they've never moved to market faster than with this product launch of 3D products. So basically, I'm wrapping up here in terms of summary. I was thinking about this last night. I feel like we're going through an evolution. It's disruptive, but boy, is it exciting to go from 2D to 3D, right? From the abstract concept of mathematics to the concrete example of which I showed you. From rote memorization of what is a T-Rex, what is the size, how many bones do they have, why is he ferocious, to actually printing out a model and seeing it and putting those pieces together. We're also seeing something fascinating is that education around 3D printing is more collaborative. There's storytelling. Why? Because people are printing things, they want to tell someone, they want to share that story. So we're seeing that there's an impact on collaboration between students, between ages, and between students and the teachers. And in the last example with Florida Poly, there's actually more of a collaborative nature with the neighborhoods in which the schools are located. And there's this idea of pioneering, that you're creating something new, fresh. I have to say my first experience with 3D printer is I went into one of our MakerBot stores before I joined the company. I took a 2-hour class and I designed a snowflake. Boy, was that simple. But you know what? A 2-hour class where you work with CAD design, you take basic geometrical designs, you replicate the pattern, and then 2 hours later you see it's printing. And I walked out there and that was probably one of the most magical moments that I've had since building like a cool Lego design when I was 5. But there's this idea of pioneering and creating and empowerment. One slide on MakerBot. Our founder, Bree Pettis, was actually a teacher. And his idea behind 3D printing was, well, why should 3D printing only be accessible to professionals? Why can't we bring this into the schools? So actually over the last 6 years, the company is 6 years old, we've been building a 3D printing system that is meant to be accessible. And at the heart of this is educators and teachers like Bree. So we have a mix of products, hardware, accessories, apps, new filaments. We just announced 2 weeks ago that we're going to be having a new texture to which you can print with. This is basic PLA, corn-based biodegradable plastic, and we're announced that we're coming out with a filament that is made with iron, limestone, and bronze. So you'll be able to actually print something that has the weight of, not exactly the full weight of bronze, but has a more similar look and feel to bronze, limestone and iron. In terms of solutions, the company has grown a lot. And part of the reason that we've grown is that we have had amazing clients that have come to us and said, okay, we want to open up an innovation center, help us figure this out. We don't know how to do this. So as the needs of our clients have grown, we've come forward with consulting services, design services that Sesame Street used. We've also significantly expanded support. The MakerBot folks are inherently engineers, they're tinkerers, so something that we think is, well, that's easy to do, actually, may not be easy to do. And so what we've done is actually we've developed a pretty robust support system so that when you buy a MakerBot and you register, you can actually get a huge database of support online, lots of videos, lots of tutorials, and if you have more complex projects, you can actually buy more advanced support. And then in terms of designs, I mentioned the free community that we started that has over 500,000 free designs called Thingiverse, and that continues to grow. So, a couple of points. 3D isn't perfect, right? So many people are out there saying that it's going to be the second coming and it's fantastic and it's easy and it's point and shoot. It's not. It actually takes work. And when you work with these printers, it's mechanical. You're taking plastic and you're putting it into what we call a smart extruder. You're heating it up to 450 degrees, and then it's additive manufacturing. And over hours, for example, the T-Rex 24 hours, what do you do for 24 hours in your normal life? But for 24 hours, that printer is printing. Well, guess what? Sometimes there are clogs, sometimes there are errors, and you just need to dig in and work through that. So please don't walk away thinking that it's a simple point and shoot, set it up and walk away. You actually need people that are involved and passionate about it and committed, similar to the folks that we featured in some of the videos. One size doesn't fit all. Florida Poly took one approach. The Whitby School took another approach. Tap passion. What we found is that as I meet clients, whether it's at GE or at the Whitby School, find people and if you have people working on it, have them tap into their passions, whether it's the derby or other items. Unleash your creativity, have fun with it, share and inspire. We're at a very early age, so your lessons that you experience with this is so valuable for other teachers, for other educators. It's a great way to go out there and share what you're doing and how you're doing it. Second to last slide. These are actually my kids. Nick is 17. He's a senior at the Taft School at Waterbury. Xander in the middle, he's 15, he's a freshman, and Katie is 11 and she's in 6th grade. So when I first joined MakerBot, I brought home a printer. And actually I wanted them to go through the unboxing experience. You know, I'm a marketing guy, so I'm like, all right, let's see how they can do this. Well, guess what? They unboxed the printer, they set it up, and they started using it. I sort of hung back, and actually what was fascinating to see is that instead of sitting there and going online and watching videos on YouTube or playing video games, they actually started going onto Thingiverse, downloading models, whether it was horses for Katie or other items for the boys, and they started printing. And actually the weekends started becoming print fests. The transformation with my kids was actually pretty amazing. I think Patrick mentioned also with his son how when he got involved in it, it really changed the way the kids think about it. My son had just finished his college applications. Boy, that was painful. But he finished his college applications, and guess what? He's applying to engineering schools. And I really think that because a year ago he got this experience with a MakerBot, with creating something, that made him start thinking about the, creation in a different, creating and mechanical design. Xander, he's starting a MakerBot or a 3D printing club at the school, and Katie is my entrepreneur. She actually has a company that she's starting with Schleck horses, and she wants to 3D print saddles and accessories, and with a friend she's actually printing this stuff. They're photographing it. She's creating a website, and she's intending to launch that. And she's like, come on, she's 11 years old. So and I think a lot of that comes from just seeing the magic of what you can create with. So Thank you. Thank you very much. I very much appreciated your time.
Thank you, Yuri. Okay, so just two more things, actually three more things. If you would like to earn professional development credit, remember to get scanned, and they will be added to your Veritan report after the event, and we'll be sending you an email with all of that information. Remember, first of all, there's a coffee break on the show floor this morning, and then we have our coffee break this afternoon where you can pick up your FETC commemorative mug. You can also pick up your FETC commemorative t-shirt in the final keynote of the show tomorrow. The exhibit hall is now open. Be sure to check out the full list of learning labs, Aspire sessions, STEM demo classrooms, 480 vendors with educational opportunities, and have a great day at FETC.